This presentation is about charting proficiency test results in the long term. Why should we want to do this? Let's have a look at an example result from a laboratory, lab number 28 in a FAPAS proficiency test. Lab 28 has got a Z-score of 2.1, and we can see this highlighted on the histogram. The question we are asking is, has Lab 28 passed or failed the proficiency test? Before we can answer that, we need to consider what is the underlying statistic of the proficiency test. The Z-score is based on the normal distribution. This is the bell-shaped curve which should be familiar to analytical chemists. With the normal distribution, the area under the curve within two standard deviations, here and here, is about 95%. Another way of looking at this is that outside of two standard deviations, there is about 5% of the area under the curve. In other words, there is a 5% probability, or a 1 in 20 chance, that a Z-score outside of 2 is actually part of the normal distribution. So let's bear that in mind as we look at the rest of this presentation. Going back to our question, has Lab 28 passed or failed the PT with a Z-score of 2.1? The answer is that it's neither a pass nor a fail. It's that grey area, that 5% probability that it might be part of the normal distribution or it might not. So, how do we resolve this? This is our hypothesis that we are testing. Are we part of a normal distribution? So, in general terms, is our laboratory operating normally? Are we achieving 95% of our Z-scores overall within plus and minus 2? Overall, in general terms, are we achieving about 5% of Z-scores greater than 2 but less than 3? So, do our Z-scores fit the normal distribution? A secondary question is the median of our Z-scores close to 0? This will tell us if there is any bias in our method. The best way to answer this is to build a control chart. We need data for a control chart. So a very simple control chart with only a few data points doesn't really tell us enough information. We need a lot of data points, preferably 100 or more, on our control chart. This tells us that the majority of our Z-scores are within the performance limits plus and minus 2, but also they are centered around 0. In other words, we're not seeing bias in our performance. You can create your own control chart, and there are publications to help you do that. Alternatively, there is an online facility when you log into your account on the FAPAS website. go to the Charts tile on your account, and this enables a feature. There is further documentation under technical documentation on the FAPAS website to help guide you, but this presentation goes into some of the details to talk you through this process. When you select the Charts tool, this is the first page you are presented with. You need to retrieve the data that are relevant, so whether it's for you as a sample contact or for your company. You can select the date range, and by default it will list all the analytes that you've taken proficiency tests for and all the matrix combinations. So the next part of the process is to filter the data to what is relevant. In this example, I've selected all the company results for the analyte group of mycotoxins and the matrix group of animal feed and pet food. There are 14 mycotoxins listed and 2 feed matrices, so we can now filter this even further. We can also filter by the analyst if you have used the multiple result submission feature of the website in any of the proficiency tests. I've now filtered the analytes, and these are now shown as green boxes. I've filtered one of the matrices for animal feed, but I've not selected cereal-based feed. I've selected all the analysts, and now I have my overall combinations ready to chart. There are 2 options now. You can plot the chart online, or you can export the selected data, and this will provide you with a file in the format that can be read by any spreadsheet package. A basic chart on the online version would look something like this. We see individual Z-scores across a date range and the -2 and +2 Z-score limits. The points are colour-coded according to the analytes. You can change the date range, you can zoom in, and you can reset the date range with these buttons. Further information is provided down at the bottom left. It shows the percentage of Z-scores within ±2 and those outside -2 or outside +2. So this gives you your indication as to whether you're complying with that normal distribution. We also get a measure of the bias. This is the percentage of Z-scores greater than 0 or less than 0. If you had a larger proportion of Z-scores greater than 0, that would indicate a positive bias in your results. Similarly, a greater proportion of less than 0 Z-scores might indicate a negative bias. A more complex or advanced chart can be created, especially if you have multiple results submitted. Here we can see not just the company Z-scores, which are indicated by circular symbols, but analyst-specific Z-scores indicated by triangles. Hovering the pointer over one of the points brings up the detail in a separate box. So here we can see the analyst, their Z-score, and any information that the user has entered that is pertinent. In this example, different methods. You might also want to go further into the information that is already there in your account. So you can bring up a dialog box which will give you further information, and the links will bring up the report relevant to that proficiency test, the certificate of participation, and if you want to be able to see the same proficiency test or related quality control or reference material products, there is a link to similar products. This saves you going back into your account and trying to search for these products or reports separately. So, overall, the charting tool provided on your account on the FAPAS Secure website gives you a lot of information that you can use to interpret your Z-scores and ensure that you can answer that question as to whether your performance is normal or not.